Okay guys, so now we're going to use the application, okay? So we're kind of incorporating example 8 with this. So 9a says the edge of a cube is measured as 10 centimeters with an area of 1%. The cube's volume is to be calculated from this measurement. Estimate the percentage error in the volume calculation. So let's use a variable. So let x be one side of a cube. In this problem, one side is measured with 10 centimeters. Well, let's find the volume. So volume with respect to x of a cube is x to the third, because it's length times width times height. Since the cube, all sides are the same. Well, let's find the derivative with respect to x. So this is the change in volume with the change in the one side. So this is 3x squared. dv represents just the change in volume, so we're going to cross multiply. So now we have 3x squared times dx. This is the change in volume with respect to x, okay? Well, since x is 10, and remember, it says here the measurement has a 1% error. Well, that means the change in x, which is the change in the measurement of one side, is going to be 1% of x. Well, 1% is 0.01 times 10. So as you can see, the measurement has an error of a 0.1 of a centimeter. So since our volume is x to the third, which has a volume of 10 to the third, which has a volume of 1,000 centimeters cubed, the change in volume that has the error is going to be 3 times, well, this is what I'm using right here, guys. 3 times x is 10, so that's square. dx we calculated from here, so that's going to get multiplied to here. So that's all of this is going to give me 30 centimeters cubic. Okay, so the change in volume is 30 centimeters cubic, but this one says estimate the percentage error. Now, if you look back at your notes, I gave you guys a formula. The percentage, okay, the estimated formula, I gave you percent change in your formula is df over dA. Okay, now, and then times it by 100. Well, we don't have f or dA, we have dv, okay, with respect to f of a, which is your volume. So the change in volume, this is dA, I think in your formula, this is going to be a parentheses, over volume of 10. So the change in volume divided by the volume when the side is 10, and then times 100 because it's going to be percentage. Well, we have dv, which we calculated as this. So dv is 30, volume is this, so that's 1,000, and we have to multiply by 100 because we want percentage. So student, this comes out to be 3%. Okay, so the estimated percentage of error for the volume is 3%. All right, B said, suppose the Earth were a perfect sphere and we determined its radius to be 3,959 miles. So 3,959 miles with an error of 0.1 of a mile. The Earth's surface area is to be calculated from this measurement. Estimate the percentage error in the surface area calculation. And obviously, guys, you know, I love application, and this is as real as it's gonna get, right? So anytime you guys, we human, do anything, there's always going to be some sort of an error in calculation, or an error in measurement, or just could be called a human error. So here we go. So let's start with the surface area, which is S, which is going to be 4 pi r squared for a sphere. Then we are going to try to do the derivative, okay, the change in surface with the change in radius, 8 pi times r, and if we just want the change in surface all by itself, we multiply dr to both sides, so 8 pi times r times dr. Okay, so that is that for now. Well, let's go back and check really quickly. you guys, it says we have an error of 0.1 of a mile. So dr is the change, right, in the radius. And the radius is going to be 3959 miles. So the change in surface area, we're going to use this formula, which is 8 times pi. Radius is 3959. The change in radius is 0.1. We are going to bust out my calculator. Okay, this is going to give me 9950, and then surface area, so miles square. Okay. Now it wants us again to estimate the percentage, and again we are going to use the same formula from your notes, which is df over f of a, because it wants percentage, so we will multiply this by 100. We don't have f or f of a, we do have the change in surface area with the surface area when the radius is 3959, and again multiply by 100 to get percentage. We calculated ds already, which is this number. So that's going to be 9950. Let's see, when we want to plug in s of the radius of 39, so that's going to be this formula. So hold on tight, okay? 4 times pi, 3959 square. And I'm definitely going to need a calculator. I need to multiply by 100. So with my calculator, it's going to be super tiny because you got 3959 square in the bottom. 0.00505%. So the change is really, really small. All right, guys. So that's it.